Okay, welcome back once again to the Calc 3 class notes. We're in our last section of chapter 12 now, section 12.6, where we're going to need to understand some basics about graphs of quadric surfaces. I will say right away I don't get too nitty-gritty into the detail here because this can really get out of control. I just need you to know some very basics of this. And then we'll finish up our section, or our chapter 12, Vectors in the Geometry of Space, so we can finally get on and move on to the calculus of space. Okay, so we're on page 21. And first of all, we want to look at cylinders. Now, you probably think of a can or something when you think of a cylinder, but a cylinder mathematically is a surface that is generated by moving a straight line along a given plane or curve while holding the line parallel to a given fixed line. Okay, I think of it this way. These equations involve only two variables. Thus, in space, the third variable can be anything. So just plot the equation as you see it, then slide it parallel to the axis of the variable that does not appear in the equation. For example, let's sketch the surfaces y equals x squared and y squared plus z squared equals 9. So first of all, let's look at y equals x squared. That's this guy. So I first have to sketch y equals x squared, which in the xy plane is this. And you got to remember, we're kind of looking down on this at like almost a 45-degree angle from in the first octant, looking down towards the origin. So this is what y equals x squared would look like. Then I imagine holding this with my finger and sliding it up and down the z-axis. Now it would go infinitely up and down the z-axis, but what it makes is sort of like a I don't know if you've ever skied, like a half pipe, something like that. Hopefully you can visualize that. Y squared plus z squared equals 9 is this cylinder. This one does look like can. I guess it would be called a full pipe. I don't know, but y squared plus z squared equals 9 is simply a circle of radius 3 in the yz plane, which is this guy, right? A circle of radius 3 in the yz plane, which is this guy. And then I take that circle and I slide it along the x-axis infinitely, and it traces out this cylinder like this. So because z could be anything here, I slid it up and down the z-axis. Because x could be anything here, I slid it up and down the x-axis. And that allows you to visualize what you have. So I would expect you to be able to draw, as best you can, simple cylinders like this. Nothing too complicated, nothing too away from the axes, etc., etc. Just need you to understand how to get the basics of a cylinder. Okay, now a quadric surface is the graph in space of a second degree equation in x, y, and z. In other words, we're going to study quadric surfaces. This is the general second degree equation. Okay, ax squared plus by squared plus cz squared plus dz equals e, where a, b, c, d, and e are constants. Okay, the basic quadric surfaces are ellipsoids, paraboloids, elliptical cones, and hyperboloids, and I'll talk about them specifically in the next video.